Hey everyone, so today we'll be learning how to solve rational equations and inequalities. We'll be going through the examples over here, and in the process of doing so, I'll show you guys how you can solve the steps required to solve um, equations and these inequalities. Each one is 7 minutes long-ish, so yeah, even though you see like it's a 30-minute video, each one is around technically 7 minutes long. And yep, I also included timestamps for things you should be watching out for. They're kind of embedded in the video, so if you guys are just wondering about that, you can click on those timestamps. And yeah, good to go. Okay, so let's get started. So the first thing we need to do is to figure out what the common denominator is and multiply each term with it. So how you figure out the common denominator is the stuff in the fractions. So these guys are the fractions that we have. So the common denominator is just whatever is at the bottom of your fraction multiplied together. So since we have 3 and x plus 1, our common denominator is going to be 3x plus 1. So I'm going to write it out over here. So our common denominator in this case is 3 times x plus 1. Sweet. So now all we do is we multiply each and every term we have here with this guy. So what we mean by terms is any group any group of numbers that are separated by subtraction or addition signs. So in this case, since these guys, circle them over here. Yep. These guys are separated by subtraction signs. Each one of these, so you might be wondering why we don't consider these guys as terms, because they're separated by a plus sign. Well, they are terms, but they're terms within a larger term over here. So in this case, when we're solving these equations, we don't consider these guys as terms, even though they are. We kind of ignore them. Any plus or minus signs within the fraction, we don't look at them as terms when doing this. So we only consider like the big fractions like this, and like these numbers, separate numbers over here. Okay, so let's do it. So you write it out. 2 over x plus 1 plus 1 times 3 x plus 1 minus 2. So 3. Okay. Make this neater. Minus 2 times 3 x plus 1 equals 2. X times 3 minus 2 over 3 times 3x plus 1. Alright, so we multiplied every single one of the terms that we highlighted with this. So the second thing we do is we cancel stuff out and expand everything. So if you notice here, what we have are things that we can cross out. So over here we can cross these guys out. We can't really cross anything out over here. This is, we can leave it, and we can simplify this because we can cross these 3's out. Yeah, let's do that. Okay. So the next step we do is we just simplify and we expand everything. So each one of these guys, we have brackets, we have stuff being multiplied and subtracted with each other. So what we're going to do is just expand everything out, get rid of all our brackets, and then simplify as much as we can. Yeah, so that's what we're going to be doing. Okay, so we have 6. 2 times 3 is 6. Wait, and that's it. 6 x plus 1 equals 2 3x. Okay. Oh wait, that's not 6. It should be 2. Okay. Nice. Alright, and then we just keep going. We just expand everything, I guess. So we have 6 minus 6x minus 6 equals 2. 3x squared plus 3x. So we pretty much simplified some stuff. We can keep going, but we're going to move on to the third step. Okay, so the third step is to identify the type of equation we have and solve accordingly. So if we look at what we have here, after we simplified a bunch of stuff, this guy is a quadratic equation. As you can tell, quadratic equations have x terms that are squared, and the rest of the terms are lower degree. So any exponents that are 1 or below. So yeah, this is our quadratic term. And then these guys, all of these guys are either degree 1 or 0. So we can solve this just like a quadratic equation. If you remember how to solve these, all we have to do is to have 0 on one side and everything else on the other side. So that's what we're going to do. So we can do 0 equals 2, 3x squared plus x minus 2 plus 6x. We're going to move that guy. So you have 3x squared plus 7x plus 2 minus 2. Yeah, equal to 0. Okay, so hopefully I didn't do any calculation errors. Something doesn't sit right with me, but we will find out. Hopefully this is right. Okay, so we can factor this, but I don't see a way that we can factor this one using any format, so we're going to use a quadratic formula. Okay, so x equals negative b plus minus. Okay, that's an A. Okay, we plug our stuff in. Negative 7 plus minus. We have 7 squared minus 4, 3, negative 2, all over 2a. Oh wait, 2 times 3. 7 plus minus 49 plus 24. I think it is. 49 plus 24. Yeah. All over 6 equals to minus 7 plus minus 73 over 6. Okay, so there are your two answers. We have the first one, which is x equals negative 7, the plus version, over 6, or negative 7 minus root 73, 6. There you go. That's how you solve the equation. So the next example we're just going to do, and it's pretty much following the exact same steps, just different numbers. Yeah, so let's go ahead and do it. Okay, here's our next example. So we're pretty much going to go through the same process. Even though it looks a little bit more complicated from before, everything just stays the same. All the steps are different. We just, there's just more stuff. Okay, so the very first thing we do is we find the common denominator. So let's do it. This is a little bit tough since we don't have nice factor things at the bottom. What we're going to do is we're going to factor the bottom of this guy here. And you're going to see why we do that in a minute. Okay, so we have negative 3 over 2x plus 1 minus x minus 1. So if we factor this, we have 2x plus 1 and x minus 3 equals negative 1 over 2. So the reason why we factor this is we have these two guys that are in common denominator. So usually what we do is we multiply everything in the denominator together, and that gives us a common denominator, right? But in this case, since we have something that's repeated, we actually don't need to include one of them. We can take out all the repeats. So our common denominator in this case is just going to be, let's write it, 2 times x minus 3 and 2x plus 1. We don't need the second one. So yeah, in general, it's just a really good idea to factor your denominators first in your rational equations, so that you can kind of look at it to see if there's any repeats. That way it's a lot easier to get your common denominator and simplify stuff in the future. Yeah. Okay, so let's do it. Let's multiply each term now. So we have -3 all over. I'm gonna write it over here. -3 over 2x plus 1 times 2x plus 1 x minus 3 times 2 minus not fun. Alright, x minus 3 2x plus 1. Alright, this is like the most tedious part of the process, but it's after that it's kind of smooth sailing. Okay, equals 2. X minus 3, and then 2x, crap. 2x plus 1 times 2. Alright. We're good. Okay, on to step 2 now. We just have to cancel everything out and simplify. So, even though this thing is long, a lot of stuff's going to cancel out. It's going to look really nice, and it's going to be a lot simpler than it looks. Okay, so in the first thing that we have, we're going to cross these guys out. The second thing is, if you look at the other one, we can actually cross out all of this stuff. All of this stuff simplifies out. Okay, and last but not least, we have that guy, and we can't do anything to that. Oh no, we can. We can cross out this. This is actually supposed to be a 2. It just didn't show up. Okay, yeah, these guys are gone. Okay, so over here we have -3 times 2, so we have -6 x minus 3. Alright, so this is the part where we kind of have to be careful. As you see here, we have a negative sign, negative this guy times 2. So this guy's actually kind of in brackets, because in the beginning the subtraction sign came over here. So since we're subtracting this whole thing, we technically consider these guys to be in brackets when we do this. So yeah, very important that you remember this. A lot of times I see, like, when dealing with this, we have negative x minus 1 without the brackets, but there should be negative bracket x minus 1 close bracket, and that actually affects the solutions a lot. Yeah, that's usually where mistakes happen. Okay, so yeah, let's write this. Negative, we have the 2, so we can put the 2 in the front, bracket x minus 1. Okay, equals 2. Same thing here, the negative sign is still here. Negative x minus 3, 2x plus 1. So we're going to pause here. We can still simplify and keep going, but we're just going to go to step 3 right away. Yeah, because we can actually do step 3 before finishing step 2, which is nice. So over here, once again, we have a quadratic equation here. We can tell because we have this negative 2x squared term, and the rest of these guys are like degree 1 or less. So we can solve this just like a quadratic. We just have to move everything to one side and 0 on the other, and then factor it, or use the quadratic formula. So let's do it. Alright, so there comes a point when you do quadratic equations where you try to figure out if you can factor using some, like, you know, and then you just say, fuck it, use the quadratic formula, because it always works. This, for me, is one of those moments. My hunch is that it can't be factorable, or it can't be factored, but I'm too lazy to check. We're just going to plug it in and see what happens. So I put in the quadratic formula. I didn't do it here because we're running out of room. But basically, the two answers that we should get are 13 minus root 33 over 4, or 13 plus root 33. Cool. And we are done. Yeah, let's circle this. Yay. Alright, there you have it. When you're doing these, always be wary of these negative signs. They actually trip us up quite often, actually. See that happen multiple times as a tutor / teacher. Make sure that when you simplifying these, that after you simplify, these guys are actually in brackets. So that happened over where'd it happen? Over here. Yeah, we wrote it out. We kept the brackets here. This guy came from this. So you have negative bracket x minus 1. And yeah, you should be happy. Okay, and that's it. That's solving rational equations. So let's do this. Solving rational inequalities. So this is a little bit different from solving equations. The process is slightly different. We do very similar things. But yeah, I'm going to show you how you can solve these guys. So the first thing we do is we're going to actually put everything on one side of the equation, so all the terms on one side, and 0 on the other. So yeah, this is a little bit different from solving equations. We don't find the common denominator first. We just hoover everything on one side and have 0 on the other. So if we look in this case, we're just going to move this guy over. Yeah, it's just going to be much simpler. So let's do it. We have 2 over x plus 1 minus 1 over x minus 3 smaller than 0. Okay. Cool. Hopefully my writing is okay. Sweet. So the next thing we do is we find the common denominator now. And we're going to make one big fraction. So you're going to figure out what that means, making one big fraction. But first we're just going to find the common denominator for these guys. So the common denominator here is just going to be x times x minus 3. Those are the two things in the bottoms that are fractions over here. So this is going to be our common denominator. Okay, I'm going to finish the bracket here. So we're going to write this thing a little bit different this time. We're going to write it in this way. So we have 2 over x. Since this term already has an x, we just need to multiply both the top and bottom by x minus 3. X minus 3. Okay. Plus, so because this is a 1, this number is technically, there's like a mini fraction over here, over 1. So for this one, we have to multiply everything by x times x minus 3. Okay. That's what our 1 became. Minus, so this term already has a x minus 3 at the bottom, so we're just going to multiply the top and bottom by x over x minus 3 smaller 0. Okay, so there's a reason why we did this. Now each one of these terms has the same denominator. Before we didn't, so we weren't able to add or subtract these guys together, but now we can, since these guys have the same denominator now. And what we're going to get is one singular big fraction. So yeah, that's how we can get it. So at the top we have 2 x minus 3 plus x minus 3 minus x all over x minus 3 smaller than 0. Okay, good stuff. So the next step we do is we're going to expand everything out and simplify, and then we're going to refactor it as much as possible. So the reason why we do this is we're setting up to do our interval line and graph. over here. And you'll figure out what that is. But pretty much all this stuff we can simplify it, and then we're going to try and refactor it again. Okay, so let's expand everything out. Okay, so now we arrived here. I just, did all the simplifying. So now we have this. So when I try to factor this, couldn't really do so. So what we're going to do is use a quadratic formula to kind of forcefully factor it. Okay, so I put in the quadratic formula. Once again, I did not show my work here, just taking up too much space. But basically, the two numbers that I got were x equals 3.64, and x equals to negative 1.65. Okay, so how we can write this out is we can write it as x minus 3.64, x plus 1.65 over x minus 3, 0. There you go. Sweet. So now we are done with step 3. What we have here is everything is in one big fraction. It's all factored, and 0 on the other side. So this is the part where we use our interval line and graph. So if you remember from polynomials, on the interval line, we just draw this out like this. And then we place our x-intercepts on the interval. And then we plug in numbers within each interval to see if it comes out positive or negative. And this is going to be a little bit different because we're actually going to add our vertical asymptotes. Meaning we're going to add these guys onto our line. So in total we are going to have four points over here, or 4 little sections, 4 little lines. Okay, I'm going to draw this bigger. Need more room. Okay, this. Infinity. So we have 3.14. So look over here. And then we have 3, which is our vertical asymptote. That's where it is. We have 0, which is also another vertical asymptote. And then we have negative 1.65. Sweet. Oh wait, no, that's not a vertical asymptote. We don't have to do anything there. Okay, so just like always, we just substitute a number between each one of these. So between here and here, 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 into the function and see if it comes out positive or negative. And our solutions are going to be the intervals that come out to be, in this case, negative, since we're looking for less than 0. So the first one, we can choose the number negative 2. So if we sub in negative 2 into this guy, we have a negative number. This is also a negative number. Negative times negative is positive. Negative 2 minus negative 3.14. This is a negative number. Negative 2 plus 1.65. That's also going to be a negative number. So overall, since we have 4 negatives here, we have a positive number, and therefore this interval is going to be positive. Sweet. So the next one, we can substitute the number negative 1 in between, since that's in between here and here. So if you do that, you have negative 1 is negative. Negative 1 minus 3 is negative. This thing, negative 1 minus 3.14 is negative. Negative 1 plus 1.65 is some positive number. So since we have 3 negatives over here and a positive, overall it's going to be negative. Sweet. Yeah, so the reason why we can do this is we just need to figure out if the number is positive or negative or not. I'm going to write these back in. So since all of these guys are multiplying and dividing each other, a negative times positive would be a negative. And then since negative times negative is positive, and since the top is negative, the bottom is overall positive, it's going to turn out to be a negative number. So this is a neat trick that you can do to save time. I do it just so I don't have to use my calculator. It takes me longer to use a calculator, like pressing the buttons and stuff. I'm not actually good at using it. So, yeah, just a trick that you can use. That's why we can do it. So yeah. So I just went ahead and filled out the rest of the intervals using the same method. But here we go. We should have something like this. So we just need to pick the intervals where we have a negative sign, since we're looking for when this guy is less than 0. So that's during these ones. And since we have a less than sign, not a less than or equal to sign, we're going to probably use round brackets here for all of them. Okay, so here we have round bracket. And this is our vertical asymptote, so 0. And our second one is between 3 and 3.14. 3.14. Okay, so let's do another one where instead we're going to have a greater or equal to sign instead of a less than sign. And there's a little bit of difference in here. There's some small details that we do need to note when doing things or solving rational inequalities with less than or equal to signs or greater than or equal to signs. There's like one small thing. Okay, so let's go ahead and do it. So we have another example here. So let's start, doing it. It's just going to be the exact same process as we did the first one. Different numbers, same process. So the first thing we do is we put everything on one side of the equation, inequality, and 0 on the other side. So here, we're just going to move this one over to the other side. Okay, so we have 2x squared minus 7x minus 30 plus x plus 1, x minus 10 minus 1 bigger or equal to 0. Okay, cool. So now that we've done that, the next thing we do is to find the common denominator and make one big fraction. So it's a little bit tougher than we're used to because we don't have nice things that are factored here. We have this quadratic at the bottom of this fraction. So what we're going to do is, just like in the rational equations, we are going to actually factor this guy, and we're just going to see if there's any factors that are in common. That way, when we find our common denominator, it may be a lot simpler than we thought of originally. So let's do it. We have 2 x minus 10 x plus 3 plus x plus 1 all over x minus 10 minus 1 bigger or equal to 0. Okay, so once we did this, we were able to figure out that, there's some common stuff over here. So our common denominator is actually just going to be x plus 3 and x minus 10. We can kind of forego this last one since it's common for both fractions. So our CD, I'm going to write up here actually. CD is going to be x minus 10, x plus 3. Nice. So we're back. I just kind of did all the grunt work over here, changed all the fractions so now they have all the same denominator. And now we're able to create one big fraction. So we're ready for step 3. So step 3 is we just have to simplify and factor the numerator as much as possible. So over here, what we're going to do is we're going to expand all of this stuff. That way we can collect all the like terms and see if we can factor it. Okay, so let's do it. So, pretty much skipped all this stuff. All the stuff I did over here was just expanding everything and then simplifying stuff. So just to save some time, this is what we have at the very end. We have 11x plus 35. So since this is technically already factored, we can technically put this as brackets. We are ready to move on to the last step, which is putting all of this in our interval line and graph. So I guess one thing to note before we go on is the negative sign. So this is the part where I want to highlight. So notice that when we moved the 1 over, this is -1, and when we changed it to fit the common denominator, it became this. So once we put it over the fraction, notice like we still kept the negative sign over here, just like how we did in solving the rational equations. This is very important. So this negative is actually going to affect all the terms over here once we FOILed out these two, or expanded these two brackets, which we can see here. Always kept the negative sign, since originally the subtraction sign is subtracting this whole fraction. When we FOIL this out, this subtraction sign is going to affect each one of these terms over here. So yeah, just a side note. Okay, so let's get on with our interval line. So we can put all this stuff over here. We include, in this case, -35 over 11, which is over here. Okay, -35 over 11. And then we also include our vertical asymptotes, -3 and 10. -3 and 10. So there's a reason why I put these little dotted lines to tell myself that it's a vertical asymptote, and we'll see right after we get our solutions. Okay, so plugging in the numbers, something between -infinity and -35 over 11 is -4. So this guy's going to be negative. And this guy's going to be negative. This one's going to be negative. So overall we have a negative sign. Okay, this one, I guess -3.01. Let's try that. So -3.01. This is going to be negative. This is also going to be negative. The top part is going to be positive. So overall, this thing is going to be positive. Okay, so I finished the interval table using the exact same way, just plugging in numbers between the intervals given here and figuring out if the number is positive or negative. So let's go ahead and write our solutions. So this is the part where the signs are a little bit, or yeah, it matters that it's a bigger or equal to sign, and it matters that these guys are vertical asymptotes. Since these guys are vertical asymptotes, if we graph this out, the function is never going to cross -3. So we actually don't have a point at -3. This is an asymptote. So the function is actually just going to get really close to -3 and never touch it. Which means that when we write our solutions for this, we actually have a round bracket for -3 and a round bracket for -10. Because these guys are no longer points. These guys are asymptotes, unlike the -35 or 11. Because this guy's a point, we can actually use the square brackets for this one, since this number makes this guy equal to 0. That way we can use the square bracket for this one since it's a point, but we still keep the round brackets for the -3 and 10. Okay, so writing it out, we'll have x is the element of square bracket 35 over 11, -3, and it's a vertical asymptote, so round bracket, and then 10 to infinity. And we are done. Yep, so pretty much this is pretty much the steps to do it. Yeah, and the only thing to watch out for is when you're doing these inequalities involving greater to or equal to signs or smaller than or equal to signs. The only thing you have to watch out for these ones is once you're writing out your solutions from your interval table, you have to think about which one of these guys are vertical asymptotes. And the ones that are vertical asymptotes, if they're involved in your solution, you still have to use a round bracket because they're not points. These guys are not points. These guys are asymptotes. So yeah, that's pretty much it. That's solving rational inequalities. Okay, so yeah, that's pretty much it for today's video. Yeah, Hope you guys learned something. Hopefully the video was helpful. So yes, stay tuned. Be posting more videos in the future. Yep. Happy solving.